Okay, in this video, I'm going to take you through what exponential functions look like, and we're going to talk about exponential function graphing. If you remember back to when we did our parent functions, we're still going to be utilizing some of the same movements in our graph and some of the same details within our graph. So if I start with, first of all, y equals 2 to the x, this is an exponential function. Let's look at what that graph looks like. If I hit my graph button, you can see that it is a curve that has a horizontal asymptote. The horizontal asymptote is the x-axis, and that is, let's look at the table here for that. You can see here, let me go ahead and adjust the x value here. So you can see here on the graph in the table, this will take just a second. Okay, so you can see on this particular one that the y-intercept is 0, 1. So let's go back to the graph. It's passing through here at 0, 1. It's going up to the right, and it's approaching the x-axis. So you'll be able to see here that as x gets smaller, your y values continue to get smaller and smaller, and again they're getting closer and closer to the x-axis, but they're never going to touch. Okay, now let's take a look at our movements. We go back, I'm now going to add another graph to it. So now what if we have 2 to the x minus 2? The x minus 2 is our in our exponent. So as we look at that graph, let's look at the difference now. We add that graph. So you'll notice the x minus 2 shifts the graph to the right 2 places. And as you could probably guess, if we were to add 2 to the x plus 2, that's going to shift our graph to the left. Again, shifts it 2 to the left. Again, still have the same horizontal asymptote with that. Okay, let's look at another shift here. I'm going to go ahead and take that off the graph. Take that off the graph. So now let's say we have 2 to the x plus 1. Again, the plus 1 is over to the right. As you can probably guess, that's going to move our graph, excuse me, one up. So here's our original exponential curve, and then here's the new one. Again, it moves it up one place. And again, if we add 2 to the x minus 1, you can probably guess that's going to move it down 1. So we have our original curve, 2 to the x, 2 to the x plus 1, 2 to the x minus 1. So again, just like our parent graph functions we did earlier in the semester. Let's go back. I'm going to get rid of the 2 to the x plus 1 and the 2 to the x minus 1. Let's look at another scenario. Now if we put a negative in front of the value, so negative 2x, let's take a look at how that affects the graph. So there's my original curve. And you can see that when I put a negative in front, that's going to make it reflect across the x-axis. If I put the negative with the exponent, so 2 to the negative x, it's going to reflect it across the y-axis. So you can see here's my original curve. Here is negative in front, so it reflects it across the x-axis. Here is my negative in the exponent, that reflects across the y-axis. Let's look at one more scenario here. So our original curve is still y to the 2 to the x. Now I'm going to add a number in front of the exponent. As you can probably guess, that is going to stretch it. So let's take a look at what that looks like. So here's the original curve, 2 to the x, and then you can see it makes it steeper if I put the 2 in front of the exponent. If I were to take and put the value in front as being less than 1, so notice here I put a half in front, or 0.5, that's going to flatten out the curve a little bit as we make our graph. So I'm going to add that one. And you can see it kind of gets a little bit fatter, or kind of makes it wider.